Thank you all for joining. Let's actually go ahead and get started. So we are here to talk about one of my favorite subjects that I'm always excited to talk about, which is CI/CD. And specifically in this presentation, we're going to talk about CI/CD using AWS and serverless, and that's serverless with a capital S. And if you haven't heard of the serverless framework with a capital S, don't worry too much. We're going to get into what serverless actually is and does in this presentation. So we'll be talking about deployment automation using AWS. That's really the number one thing that we're here to talk about today. And then we'll also talk about deployment automation using AWS and serverless with a capital S, as I just said, and how that can work and the differences between just doing deployment automation in AWS versus AWS plus the serverless framework. And then we'll talk about, once you set up a great CI/CD foundation, what can you actually do to extend that and go above and beyond the typical CI/CD platform. But first, really quickly, I'm actually going to enable my video here just to introduce myself. I'm Aaron Lieberman. I'm the Cloud Practice Manager and Architect at Big Compass. And I've come up from an integration background with Web Methods and MuleSoft. And over the last 4 years, started using AWS much more heavily and am now certified solution architect in AWS and certified developer in AWS. And Big Compass as a whole is a boutique IT consulting firm, and we specialize in integrations and related technologies. So everyone here at Big Compass has some sort of integration experience, and we really like to use integration as a competitive advantage and partnering with companies like AWS, these type of great vendors that allow us to innovate quickly and bring innovations to our integrations, allows us to be able to deliver the right solution for our customers and our clients. So we really like to use the right solutions for the jobs that we're working on. And it's not always going to be in AWS. Sometimes it's going to be a combination of AWS plus the serverless framework, for example, like we're talking about here today. And ultimately, we focus on building connections here at Big Compass. We build connections between systems and applications and corporations. And of course, with our integrations, we're always building connections between systems and these applications. But most importantly, we're building connections between people. And that's what we're very passionate about here at Big Compass. And we believe that building connections between people is one of the most valuable things that we can do, because especially in this socially distant world today, building connections between people is ever more important, so that we can stamp out isolation and deliver great value between those connections between people and the network that we have. So during the presentation, I'm actually going to go camera off here so we can just focus on the content. And we'll dive into what we're actually here to talk about today, which is number one, deployment automation in AWS. And so we'll talk about setting up a CI/CD pipeline in AWS. But first, why are we even talking about this? What are the pain points of CI/CD and how can we address those? So number one, long-running deployments taking a large amount of effort is a huge pain point. And I'm pretty sure almost all people in IT have probably seen at least one of these pain points on the screen. But long-running deployments, I have been a part of and have heard of also, where companies can take up to a week to plan their deployments, and then their deployments might actually take a few days to actually execute. So when you're combining all of that effort together, you might be talking about weeks potentially just to think about one deployment and actually get one feature or release deployed to production. And really what this means is that now you're spending time on deployments and not innovation. You're not spending time on your releases and your feature development. You're not allowing developers to focus on what they're good at. You're sidetracking their focus on deployments. And then errors deploying. Of course, so let's say you're SSHing into a server and there's just an error in a script that you're running because it's a manual deployment. We run into this all the time, right? It actually exacerbates the long-running deployments. It makes them even longer. And it's difficult to deploy to many instances also. So we're here to talk mainly today about serverless services. But if you have EC2 instances always running that are always on, and you have many of those sitting behind a load balancer, let's say you only have 2 EC2 instances. That might be manageable for you to manually deploy to. But if you have 50 EC2 instances sitting behind a load balancer, that's going to become extremely unmanageable very quickly. And your deployments now for each EC2 instance that you spin up is going to become that much longer. And downtime on deployments. Again, I'm pretty sure we've all been through this here. It's the dreaded downtime that you run into on a deployment, and that really leads to lack of business continuity, unfortunately, and the business does not like IT in those situations. So how can we actually set up the CI/CD process in AWS? And this diagram might look like there's a lot of components on it, but we'll start to dissect it from left to right here. And so a good process flow will look like starting with source control. And it's always starting with source control. And it might be GitHub. You might also use something like Bitbucket. Whatever source control is right for you. If you want to go all AWS, that might be AWS code commit. And so once you make commits to the branches that you're watching in your source control, is when AWS code pipeline will now come into effect. And what AWS code pipeline does is AWS code pipeline is really an orchestration tool. AWS code pipeline will execute different phases of your deployment. So diving into this AWS code pipeline box here, we actually have 3 steps. And the first step is going to be AWS code build. And code build is responsible for actually building your code and creating an artifact that you can actually deploy in your deployment step. So let's say you're running a node application. This might be building all of your node modules and packaging up that deployment to be deployed via CloudFormation or other tool. So AWS code build is actually running commands to build your application. And then you have this optional second step, which is a manual approval step. This manual approval step, oftentimes we think about continuous integration, continuous deployment, but it's actually cutting off the continuous deployment piece of CI/CD. And why you would want to do that, I see continuous deployment being extremely effective in lower environments many times, but not in production. And many businesses want to be able to control and throttle what's actually going into production. So this manual approval step here is great for cutting off the continuous deployment piece of that. If your business, say, wants to deploy only every Wednesday morning at 9 a.m., right? And then you can use this as a control point to actually execute those deployments and limit the access to who's actually manually approving those deployments. And then the third step would be your deployment step. And your deployment step can be a variety of different technologies. We elected to use AWS CloudFormation here, but don't take this as the solution that would fit every scenario. This is one solution that could fit one particular scenario. So we elected to use AWS CloudFormation for our demo here today. And the reason for that is that AWS CloudFormation can deploy all of these assets that you see here on the right side of the screen. And AWS CloudFormation takes that build artifact, that code built up, and uses that to be able to deploy the code, the changed code that we saw from our source control to the AWS Lambdas here. And if any changes were made to API Gateway, for example, it could also make those changes. So this is one example setup of what you could do purely in AWS to start to automate your deployments. And we didn't talk much about branching there. So of course you want to integrate your CI/CD automation with branching, and you want to make this a good experience for your developers. And so you want to think about actually your service development lifecycle here. And your service development lifecycle many times will allow you to start to check in code to different branches in your source control. So say in your source control, you have a develop branch, and your develop branch is deploying to your development environment. And maybe you have a QA branch that's deploying to your QA environment, and your master branch is deploying to your production environment. So now for each one of these branches and each one of the environments that you have, you would replicate that code pipeline that we just talked about to each one of those, to tailor to each one of those environments. And so the architecture is exactly the same here, but now you just have code pipeline watching one specific branch and deploying to one specific environment rather than one code pipeline always deploying to all environments, because you want to be able to separate that out for your service development lifecycle and go through QA, for example, before actually deploying to production. So this is what this actually looks like in reality. And the more environments you have, the more times you would replicate this. So if you have 4 environments, for example, you would replicate this 4 times. So that's how you would accomplish CI/CD automation in AWS. It's one example of it, but let's actually talk about AWS plus the serverless framework now. And this is something that we're really excited to talk about. I think the serverless framework can drastically speed up your deployments. So let's get into what the serverless framework actually is. And if you haven't heard of the serverless framework is an open source framework allowing you to build and deploy apps. So it's completely free at the free tier. And you can do a whole lot and deliver a whole lot of value at the free tier of the serverless framework. And it's configuration driven. That's written in YAML. So it looks very similar to CloudFormation. If anyone here is familiar with CloudFormation, you're going to it's not going to be a huge leap to actually make the leap into the serverless framework. And it includes a command line interface that allows you to execute pretty simple commands like serverless build and serverless deploy to build and deploy your code once you have serverless integrated with your code. And it can deploy to AWS and Azure and GCP and more. And what this allows you to do is be fairly cloud agnostic. So there's some specific pieces that will be different for AWS versus Azure, for example, but it allows you to be fairly cloud agnostic and enable push button deployments to these different cloud providers. And when it's deploying to AWS specifically, like we're talking about here today, it actually uses CloudFormation under the hood. So when we execute our serverless deployments, it's actually going to be using a CloudFormation stack. So uses for the serverless framework, of course, it's always good to take a step back and make sure that the technology that you're using fits the use case. So it's great for deploying serverless applications. It's not going to be good and not even enabled to deploy EC2s and load balancers and things like that. But for your serverless applications and your serverless systems, it's really great for deploying your serverless framework. And speeds up your deployment by automatically provisioning and mapping. And what I mean by that is that let's say you're deploying an AWS Lambda and an SQS queue. And each message that comes into your SQS queue is supposed to invoke your Lambda. Well, serverless is smart enough to be able to say, okay, I know that I want to be able to invoke this Lambda every single time I get an SQS message coming through. And I'm going to automatically provision the mapping between SQS and Lambda. And so it allows you to start to speed up your deployments a little bit because it abstracts how you're actually invoking certain services, and it's smart enough to detect the connections between those services. And it can enable a multi-cloud strategy. So I talked about that on the previous slide, that it's fairly cloud agnostic, and you can enable those push button deployments to multiple different cloud providers if you wanted to. And the last use here for serverless framework is that it's really great with local testing and mocks of the cloud setup. So how many times have you tested an AWS Lambda, for example, locally, and it works? But then when you go and actually deploy that Lambda to AWS, something breaks, right? The environment in AWS is different than your local machine. But what serverless is great at doing is it can spin up a cloud-like environment on your local machine, so that when you're testing on your local machine, you can be more confident and ensure that when you actually deploy that to AWS, that you're going to get success there in AWS as well. And so how can you integrate the serverless framework with AWS? And this is what we're building up to, right? Your build and deployment configuration is now housed in a serverless YAML configuration file. And Jerry will show that in the demo here today in a few minutes. And so you're not necessarily creating your infrastructure as code in CloudFormation. You would be including this now in your serverless YAML, for example. And the serverless framework takes over your build and deploys your code. It can actually do both, and we'll see that in action again here in our demo, as well as an architecture diagram. And that can actually eliminate steps from your code pipeline, as we just saw. So what that does, eliminating steps from your code pipeline, might simplify your code pipeline, but it makes your build just a little bit more complex. So there's a trade-off there, and you just have to think about those and make sure it's right for you. So what does this look like in action? Now this diagram looks very similar to the diagram that we saw previously. where now, again, starting on the left-hand side, the start of all of this is going to be commits to your source control. And again, figure out your branching model there, but commit to a specific branch would now invoke your AWS code pipeline. And within code pipeline, now we have, again, this manual approval step, which would be doing the same thing that we just talked about and be used for that control point. It's an optional step that you can use in your code pipeline. And then we see only one other step here, and that's the AWS code build step now. But if we drill into that AWS code build step, there's actually two commands being run in there. And within there, there's a build step and a deploy step. So AWS code build is executing based on our configuration, a build using the serverless framework, which is patching up that code and doing the exact same thing that we just saw. It's going to give you a build artifact. And then the deploy step of code build now is going to use that artifact and be able to deploy all the assets that you see here on the right-hand side of the screen. So a very similar setup. You don't see the CloudFormation step here anymore. And we only see the one code build step that now has two steps housed within it. Again, the trade-off between a little bit more complicated build step versus including a build step and a deploy step. So what can we consider from your CI/CD automation in talking about all of this? And first of all, it's technology related, right? Technology, you want to use the right tool for the job, and there's plenty of tools that you could use for this job. And so I want to be clear on that. We're not saying serverless is right every time. We're not saying that CloudFormation is right every time. You might consider AWS code deploy when you want to, let's say, just deploy to a single Lambda or to a single EC2 instance. Code deploy is great for that and more. You might consider SAM. SAM is great for serverless applications and can do a lot of the things that the serverless framework does as well. You might elect to use SAM for your serverless applications. CloudFormation is great for AWS across the entire AWS stack. Serverless framework is great, again, for your serverless applications across your cloud providers. Elastic Beanstalk is absolutely awesome. We love Elastic Beanstalk for deploying to EC2s, especially auto-scaling EC2s behind load balancers. And then Terraform is great for completely cloud-agnostic infrastructure as code deployments. And finally, you also want to think about those different environments. So I've mentioned this a couple times now. Integrate your CI/CD automation with your service development lifecycle. And I've been on the receiving end of DevOps engineers implementing a CI/CD pipeline, and I've created CI/CD pipelines. And based on my experience, the best culmination of this is when your DevOps engineers can come in and adhere to the process that the developers are already using. Because if you don't do that, you're probably going to get some pushback from your developers, and you want to make this whole thing a great experience for your developers. So think about the users of your CI/CD pipeline, which is your developers, right? And make it easy on them, make it a great experience for them. Security is another huge consideration. So you might include security considerations if you have some sensitive data. And maybe you're pulling in that data at build time in your CI/CD pipeline. So if there's sensitive data that you want to encrypt, you can actually start to do that. And Jerry will show that in our demo today. And caching is huge. Caching would come into play when you have reusable assets that you're using for all of your deployments. So for example, if you have a node application that's using a bunch of reusable node modules, you can actually cache all of those node modules and package them up and store them so that on your first iteration, your code build might take a few minutes. It might take a little bit of time. But then now on your next iterations of your deployments, it's going to use those cached resources and bring them in without having to download them again. So now your second and third and so on, those iterations are going to become much quicker to actually deploy. And that really tailors to your pipeline automation. There's a bunch of levers that you can pull and a bunch of dials that you can turn. And caching is just one of them. So once you set up a good CI/CD pipeline, you can start to optimize your CI/CD pipeline also. And testing automation is huge too. Within your CI/CD pipeline, you almost always want to execute at a minimum your unit tests. But we're going to talk about some other testing scenarios that you can implement also. And the takeaways from all this is that AWS plus serverless framework is awesome for serverless applications. AWS and serverless only works in certain scenarios though, right? So don't try to fit the square peg into a round hole. A more diverse system might use CloudFormation or Terraform, or a more diverse system if you have always on things like EC2 and RDS plus serverless services like Lambda and SQS and SNS. You might even split those deployments up as one of the possible options that you can take, where maybe Elastic Beanstalk handles your EC2s and the serverless framework handles all of your serverless services. And I really want to stress here, the final point is that CI/CD is an evolutionary process. Just like any other project, CI/CD is iterative, it's evolutionary. So there might be low-hanging fruit for you, where a huge pain point right now is you have long-running deployments and manual steps in those deployments. And what you can do is set up a CI/CD pipeline to just address that need and really deliver a whole lot of value just in that first iteration of the project. But then after that, as a second phase, you can then come in and start to optimize. You can worry about security and caching and other CI/CD considerations, but deliver it iteratively as you would a normal service development lifecycle. And I especially want to stress that point because now we're going to talk about, a couple again of my favorite subjects and going above and beyond with CI/CD. So once you have a great CI/CD foundation, now you can start to think about really delivering a lot of value. And we're going to talk about 2 ways that you can do that. But again, don't try to bite off everything. Bite off the small chunks and deliver these things iteratively. So the first above and beyond subject that we're going to talk about once you have CI/CD implemented is QA automation. And why are we talking about QA automation? Well, I think, again, a lot of people in IT know what the pain points are when it comes to your QA cycle or your testing cycle. I'm pretty sure that we've all had bugs deployed to production and we've had to be able to roll back. And it's not a good scenario. A lot of times it's affecting business continuity when you have bugs deployed to production, and it doesn't look good for the IT team that's deploying. And it's difficult to regression test. You might have a whole lot of regression test scenarios, especially if you have a complex system or a complex application. It might be very difficult to be able to regression test, and it might be extremely labor intensive to be able to do that. And that ultimately slows down your releases and doesn't allow you to innovate as quickly. And you might also have a lack of understanding of use cases. And this wouldn't be because somebody is incapable of something. It might just be because there's lack of documentation. There's always going to be turnover in organizations, and if somebody in your QA team leaves and there's not good amount of documentation to replace them and have somebody to come in and know everything that person knew, well, then that person's probably going to have blind spots, and it's going to be difficult for them to be able to test all the scenarios because they don't know what they don't know. And so your QA automation scenarios probably look something like this, where you might have UI testing automation that you can think about, and unit testing and regression testing and load, stress, and security testing also. But again, I just want to stress here that this can be an iterative approach. And I would also stress that I personally would bite off unit testing first. And then I would probably move on to the other types of testing here, like regression testing. Regression testing would be a great second phase of automating your QA cycle. And what you can do is you can build this in now to your CI/CD pipeline. And that's where it all starts, is a well-defined DevOps, right? You want to have those processes nailed down. You want to have your CI/CD automation nailed down before you even start to think about this, because nailing down that design will allow you to open up these possibilities. And then once you have a well-defined DevOps, you can then gather requirements and capture the QA test cases. So you're probably going to involve potentially multiple people or the entire QA team to capture those test cases and document them. And I can't stress this one enough. This one is really, really important, where just capturing those QA test cases at a minimum will make your QA cycle repeatable for anyone. And then you can design your automated testing suite. And this is really where the magic happens, right? There's no magic bullet here. You're going to have to design based on the system that you want to test. And then you can implement functions to run through all of those tests. And we'll look at how that might look here in a second. And after that, you want to have the visibility into what that test looked like. So you always want to be able to create a testing report as well. And in practice, this is what that might look like. And this is a great oversimplification here, right? So again, this is not a magic bullet. This is not how it's always going to look. But let's assume for the purposes of this discussion that you have some EC2 instances sitting on the right-hand side of the screen here behind a load balancer. And your system has some hooks that you can hook into. And maybe it's API driven. So what you can put in front of that is an AWS Lambda, for example. And that AWS Lambda here now would really be where the magic happens and where you'd implement your automated testing functions. So those automated testing functions would go through what you had inventoried and documented as all of your QA test cases and be able to now start to hook into your system to automatically test all of those use cases. And that Lambda might be invoked by an Amazon API gateway, and it might dump its testing report out to an S3 bucket so that when it's done, we could actually gather that report and see what happened and have the visibility there to be able to see what happened. So automated testing considerations, there's a whole lot of these. But again, number one, unit testing is the chunk that I would bite off first. And you want to think about your test-driven development there. For the rest of the types of testing, you might want to think about tools even that you can use. So for UI testing, I would highly recommend not trying to develop a custom solution for that. I would use something like Cypress or Selenium. For regression testing, you might implement a custom solution, or maybe even just developing a Postman collection is sufficient for your use case. And automated testing considerations, in terms of considerations that you're going to have to think about in design, is changing requirements can actually mean altering your automated testing suite. And I've run into this before. All you want to do here is in design, you want to try to mitigate this risk as much as possible and think about making your automated testing suite as configuration driven as possible. And always, always, always run unit tests where possible. I know I've said that a few times now, but this is going to smoke out probably 80% of the issues that you have in your deployments. And CI/CD integration to automatically test before each deployment. So again, if you have your DevOps processes set up and it's automated, you can use that CI/CD integration to be able to automatically test now before each deployment. And finally, the last above and beyond subject is provisioning new AWS accounts. And this gets quite a bit more complex, but why would you want to actually provision new AWS accounts? Well, you might want to provision new AWS accounts because you want to achieve account isolation, for example. You might want to separate your development environment from your QA environment from your production environment. Or maybe you want to separate customer traffic. And your customer A versus customer B versus customer C might all have separate accounts to be able to separate their traffic. You might have different tenants of your SaaS solution that you want to be able to separate their traffic. So there's a variety of different ways that you would want to be able to isolate your accounts. And it might be difficult to sell your SaaS solution right now and difficult to monetize that SaaS solution. So actually spinning off new child AWS accounts to roll up into your master account can help you monetize that solution. And time taken to manually deploy new accounts is a huge pain point. So think about if you're already struggling with deployments within a single AWS account, think about spinning that off to 50 new accounts. You really want to have your CI/CD and DevOps processes nailed down because the time taken to manually deploy to new accounts will only multiply if you start to get into this area. And so how would you actually start to create an account, a child account, that would be linked to your master AWS account to resolve any one of those pain points that we just talked about? Well, first of all, I think the obvious one is creating a new account. And the AWS tool that you would use to do that, or tools, is AWS Organizations and CloudFormation. And Jerry and I are happy to dig more into this. We're not going to dive too deep here because it can get pretty complex. But to create a new account, you would think about AWS Organizations and CloudFormation. But then the second one that sometimes can go hidden and that you have to think about even more is updating that existing account. So if you have 50 child accounts that are rolling up into your master account, you're going to want to think about updating those accounts for when releases get pushed. and for when changes get made and when major and minor versions go out. And that's when you want to hook into your CI/CD pipeline and make sure that that process is very well nailed down so you can handle this management piece as you scale out to multiple accounts. And so what do you want to consider for account creation? Well, number one, again, no size fits all. That's been a theme throughout this entire presentation. You might want to separate out your serverless services based on Lambda and SQS and SNS from your EC2 deployments. And you can use less Beanstalk, for example, for EC2 versus the serverless framework for your services, for your serverless services. You're going to want to think about monetization. So you might want to create some great reusable dashboards that can be viewed in your master account so that now you can start to charge your customers or tenants of your solution appropriately. And versioning. In terms of versioning, you're going to want to think about, do I want to push all versions out to all accounts that I have, or do I want to selectively actually update the different accounts that I have? Well, it's again, not a one size solution fits all. Account management is huge. So as you start to spin up new accounts, your account management is only going to get more difficult. So you want to be able to mitigate this by planning for it up front. And then account access. Do you want to actually give account access to the different child accounts that you're spinning up? Maybe not. Maybe you only want to be able to access those child accounts from your master account. And this is my absolute favorite slide, last one before our demo here. The whole point of all of this now is develop a great CI/CD pipeline and automate that pipeline. That's your low-hanging fruit, probably the most value that you can deliver. And then you can start to hook into that based on QA automation and account creation. And really what that creates for you is almost limitless possibility. It allows you to move much faster. And that gets you into a state of DevOps nirvana. So once you implement that CI/CD pipeline, now you can start to extend that and really deliver a whole lot of value. So without further ado, I'm excited to see this demo. I'm going to pass it over to Jerry, and Jerry's going to talk about our CI/CD setup in AWS and our CI/CD setup using AWS and the serverless framework. And just super quick to introduce Jerry, he might even introduce himself. Jerry is one of our DevOps experts and one of our AWS experts here at Big Compass. So Jerry, over to you.
Yeah. Hi guys, I'm Jerry. Like Aaron said, I'm one of the AWS DevOps experts at Big Compass. I have about 6 or 7 years of experience in full stack development, and I've recently started sleeping easier now that I've really picked up on some DevOps skills. So we're going to be showing a couple of projects today. I'm going to go ahead and stop my video too, just like Aaron did. We'll be showing the first project, like Aaron said, will be a CloudFormation project that integrates with Code Pipeline. And our second project today that we'll be showing to you guys is a serverless framework project that integrates with Code Pipeline, and it'll be provisioning many more resources than our first demo using just CloudFormation. So just to get started, I'm going to go ahead and share my screen. And before we begin, I'm going to go ahead and make an update to the pure AWS project to kick off our CI/CD pipeline. So this is a pretty simple project that provisions just a couple of hello world type of lambdas. One of them prints out your name. The other one just prints out hello world. Although right now it's only printing out hello Mars. So we're going to just update it to say hello world. And I'm going to go ahead and push this off to Git. Right. And this is our corresponding Code Pipeline project. And it should be kicking off already. As you can see, we have a source stage in our project, a build stage, and a deploy stage. And it's already finished the source stage, which is the stage that picks up on changes in our GitHub repository. and it's already started the code build. And we'll take a look at what the code build is doing here in just a second, because I'm going to go ahead and kick this change off in production as well by merging this change to master. So just 1 second. Shoot. All right. So this is our, this is our corresponding project on the production, in the production environment as well. And we can see that it's also started kicking off the build. We're going to go switch back to the develop project and see how the code build is going. If you click on details in a build stage, you can actually check the progress as it's going. So you can see some phase details here. A code build has a bunch of different phases, and these 4 phases, you're able to actually specify commands to run. And when I say that, I mean you can specify commands to run as if you were running them on your own command, like in your own terminal. So essentially, if you're able to build your project up in your own local environment, it's pretty straightforward to be able to do the same thing in AWS code build. So we'll take a look at the build logs to see what it's actually doing. So it shows each phase that it's entering. So there's our install phase, our pre-build phase, our build phase, and our post-build phase. And the install phase we're not really doing much in, and we'll see the build spec file that specifies our commands to run in just a second. But we can see in the pre-build, it's running a yarn install to install dependencies for our lambdas. And then we see in our build phase, it's running an AWS CloudFormation package command, and we'll dig more into that here in a second. But basically, our code build is creating a package.yaml file to prepare a deployment for CloudFormation. So I'm going to switch back over to our project here just to show how this corresponds in the project repository itself. So we saw here we had our source directory with our actual code, but now we're also going to look at a couple files that integrate with the CI/CD itself. So our buildspec.yaml file is what truly powers our code build step. So what this YAML file is this might look familiar. We had our pre-build phase that we saw in the logs a second ago. And then we had our build phase, and you can see the yarn install command that we're running there and the AWS CloudFormation package command that we're running. So it's pretty straightforward to just take your local commands that you run to build your project and just put it in a buildspec.yaml file and get up and running with code pipeline pretty easily. We're going to dig into this command really briefly. What this CloudFormation package command does is it takes a CloudFormation template file, and it takes any local file paths that are specified in the CloudFormation template file and replaces them with S3 file paths, and then outputs a package.yaml file at the very end, which is a deployable CloudFormation template in the end. So what we have for our CloudFormation template in our project repository, this is all there is right now. We see we have 2 lambdas that we're provisioning, and they both have code URIs with just the current working directory. So what our CloudFormation package command does is it interprets this template file, sees the local file paths. In this case, we only have 1 local file path that we specify in both lambdas, which is the current working directory. It will make a zip file based on that file path and upload it to S3, and then the package.yaml file that results at the very end looks exactly like this template, except there's S3 URLs in the code URI property instead of local file paths. And this is that represents a CloudFormation template file that's actually deployable in AWS, because if you have local file paths in your CloudFormation template, that's not something AWS can interpret and deploy for you. You kind of have to do this build step first. Anyways, I'll switch back over to the CloudFormation project itself, or sorry, the code pipeline project itself. And we're going to take a look at the deploy stage now. So at the very end of the build, we had that package.yaml file that I was mentioning. And this gets sent to the deploy stage. And to look at the details of a deploy stage, we could just click details here. And since this is a CloudFormation deployment, it's actually going to open up the corresponding CloudFormation stack that it's deploying to. So we can see the updates already completed. We've already deployed everything. We can take a look at the events as they happened. So we can see a few minutes ago, it finished the update and it was updating the Lambda functions and everything like that. We can look at the resources that it deployed. In our case, we're only deploying 4 resources. That's 2 Lambda resources and 2 roles for each Lambda. We can also look at the template file, and this represents the package.yaml file that I was mentioning that our code build stage outputs and sends to the deploy stage. And as I was saying, our code URIs that we saw in the template.yaml file get converted to S3 URLs that our deploy stage can actually use. So that's just an example of our CloudFormation setup that we have. And we can look at the Lambdas that we updated in the end. This was our Hello World Lambda. And as I was saying, we were outputting Hello Mars before. And now if I run a test against this, pretty simple test, we can see now it's outputting Hello World as we updated it. And if we look at the production environment and test it, we see that it's also outputting Hello World. So I believe this, let's see. We have a change going through the pipeline. I believe in production, we were already outputting Hello World. So actually this code pipeline change in production didn't really do much. But we can see in our code pipeline for production, we did have a manual approval step. And this is a difference between our dev and prod code pipeline. This is just showing how you can add as many stages as you want in code pipeline by simply editing your code pipeline and clicking add stage like that. And in our case, we added a manual approval step here that we can approve to get it moving along to the deployment at the end. So that is an example of using CloudFormation with code pipeline. And if there aren't any questions from anybody, I'm going to go ahead and move on to our serverless framework project. So moving right along, as I said, we have a serverless framework project that that provisions a little bit more resources than our CloudFormation project. In fact, this project provisions almost 70 resources in the end. And as Aaron said, the serverless framework uses CloudFormation in the background, so we'll be able to see this project in action as it's deploying and updating or creating new resources in CloudFormation. So just like before, I'm going to go ahead and just update us, make a simple update to kick off our code pipeline. This is a simple Lambda we have in our project that is just logging out a version, and we're just going to update the version. So first off, take a look here. We'll see that currently this Lambda function is spitting out a secret message. So we'll see how that works. And it's also logging the version as 1.0.6 right now. So I'm going to go ahead and change this to 1.0.7. And I'll go ahead and merge this in the corresponding develop and master branches as well. All right, so that should be kicking off our code pipelines for our serverless framework project as well. And just one thing to note here, a big difference with our code pipeline in this case is you might notice there's only a source and a build stage. And as Aaron was saying before, serverless framework is really nice because it can do your build and deployment with one command. So we're going to take a quick look at what this is doing right now. You'll notice in the build logs right now, it's showing blank. And one thing that happens with code build is it will queue your build up. And it can take anywhere from maybe just 30 seconds to sometimes longer than 5 minutes for it to actually start building. So that's just one thing to look out for if you're working with code build, is sometimes you'll have to be a little patient. But I'm going to go ahead and switch over to show how this is working in the actual project while we're waiting for this build to start. So like I said, we've got this serverless framework project, and this is actually a project we've been developing at Big Compass. It's a serverless framework accelerator project that's meant to help get someone up and running quickly with several different Lambda examples that integrate with different resources. So we have examples that key off of and push to an SQSQ, and similar ones for keying off of an SNS topic and pushing to a topic. And this Lambda that we're updating specifically is an example of having environment variable secrets passed to your Lambda function. So we'll take a quick look at how that works too. Similarly as before, we have a build spec file. And so if we open this up, we're doing a yarn install like before. We're running a yarn decrypt function. And what this command actually does is proxies to run serverless decrypt in the background. In package.json, we have specified this as just proxying to run serverless decrypt. So what our code build will do is it's using a serverless plugin called the serverless secrets plugin. We specified that in our serverless.yaml file as a plugin. The serverless secrets plugin allows you to save encrypted environment variables within your repository. So as you can see, we have a secrets.dev.yaml and secrets.prod.yaml, and these files don't get committed to Git. Instead, locally, we encrypt these files and commit those to Git, and we have to use a password when we're encrypting them. And in our code build, we decrypt these files with this command, and we have to specify a secrets password in our code build that our build spec will replace this with. So if we switch over to our code build and look at our environment variables, this is the secrets password that we've configured to send in to our build spec. So in the end, what ends up happening is this encrypted file within our code build environment, we decrypt it, and we get a resulting file that has this secret message inside of it. And then you're able to actually pass these variables into your serverless.yaml file here. Now, we're not going to go into everything that we're provisioning in our serverless.yaml file. In fact, we'll just take a quick look at the function that we're looking at. But as you can see, in serverless, you can specify a ton of different functions and resources, and you have just one code pipeline that's provisioning all of these resources. So you can pretty feasibly stand up an entire API for your use case with one configuration file and one code pipeline. So it's pretty nice in that regard. in this get secret message configuration, we see down here that we specify an environment variable called secret message, and this this basically routes to our secrets.dev.yaml file in the dev environment, and then our secrets.prod.yaml file in the prod environment. So our production Lambda gets access to secret message as well. Instead, as you saw before, it says life is good instead of the message that we have for dev. So that's how that command basically works at a high level. You also see that we were running a yarn test, which is just running some jest tests. And then we're also, at the very end, we run yarn deploy, which basically just in the same way that yarn decrypt proxies to serverless decrypt, yarn deploy runs a couple of different commands, but one of the commands is serverless deploy. And so our code build essentially just runs the serverless deploy function at the end of everything, which builds and deploys your project. And that's why our code build only needs, or that's why our code pipeline only needs a build step, because we're running the deploy command here. You could technically run a serverless package command and then do a deploy stage later in your code pipeline, but we're just showing how you can forgo having a deploy stage by running serverless deploy in your code build. So just switching back here, we see now that we do have some code, some build logs. So we see that it's entering phase install as before, entering the pre-build. As you saw in our build spec, we didn't define a pre-build there, so that's pretty much blank. Then we see a lot of things happening in our build phase, and you see it running jest coverage there. That's our unit tests that are running. You can see it decrypting that file that we were talking about. And finally, at the very end, well, actually, it's still building a bit because our build includes some bundling with Webpack and a lot of other nice things that results in some very small minified Lambda functions that have the least code possible. So our build in this project takes a little bit longer than some might take because we're doing a little bit more work in it. But so that's why it's still running. So we see right now it's bundling everything with Webpack, and in a couple minutes it should be finished up and should be deployed. So actually we see here that we've finished deploying in production, which is kind of funny. It's not often that you finish deploying in production before you finish deploying in dev, but we can switch over to production at least and see that if we run a test against our production environment, we see the life is good message like we saw in our secrets file. And then we also see the version is 1.0.7, which is what we updated it to. And our dev one should still be 1.0.6 because it's still currently being deployed. So that's just a little bit of an overview of how everything works. And this is the, this is the wrong stack. So this is a corresponding CloudFormation stack to our serverless project. This is the production stack. And as you can see, there are a ton of events that are happening in this. So it's really powerful. We've defined just a lot of YAML, and AWS does all of the hard work of figuring out, well, serverless framework in this case, and AWS does a lot of hard work in figuring out what we want and does all the work of provisioning it for us. So instead of wasting a lot of time provisioning almost 70 resources ourselves and linking them all together, we're offsetting that work to have serverless framework and AWS do it so we can spend more time innovating and relaxing on the beach and all of that fun stuff. So that was just a high overview of how serverless framework works. We would definitely be happy to talk more about some specifics behind it, especially if anyone has any questions, but with that, I'm going to go ahead and pass it back to Aaron.
All right. Thanks, Jerry. Great demo. So we just went over the demo, and I'm going to wrap up here very quickly because I see that there's some questions that I want to discuss. So next steps, feel free to reach out to myself, Aaron Lieberman, aaron@bigcompass.com, or Jerry Dixon, jerry.dixon@bigcompass.com, to discuss any of this more in depth. Again, it's something we're really excited and passionate about, and happy to walk anyone through any part of the demo or any one of the presentation pieces. And we will put the presentation and recording out to the internet, and we'll let you all know and follow up with you when that has happened. And we hope to see you next time. We've partnered with the organizer of this meetup to be able to continue presenting. And again, we have some great content here that we've been developing at Big Compass, like the serverless accelerator that Jerry talked about, like these CIC demos. So hopefully see you next time. At this point, I do want to take questions, and I'm pulling the chat back up here because I had three subjects noted down. So the first one was around monitoring, and specifically, let's see, Joshua was asking how to monitor the logs, and do you use CloudWatch or Splunk to see if the build was successful? So Jerry showed that a little bit in his demo, and just to discuss it a little bit more in detail, is there's a couple ways that you can do that. From the code pipeline and code build and code deploy steps, and even CloudFormation, you can view from the AWS console what's happening in there. And so many of the times, actually, we haven't even gotten into CloudWatch, because CloudWatch is going to be more of those lower level logs. And code pipeline, code build, code deploy, CloudFormation have really, really great logs for you to be able to determine what happened. So actually, in my experience, I think I've only had to go into CloudWatch maybe once or twice to see what was actually happening. Especially those code build logs will give you a very detailed output of what's occurring within your build. And then if you have your deploy step also wrapped into your code build step, obviously that would be in those logs as well. So Joshua, feel free to respond here in the chat, or hopefully that answered your question. And then number 2 is discussing custom deployment. So I saw a couple of questions around custom deployments, like executing SQL against Snowflake, RDS, etc. And how would you actually accomplish that? So yeah, there's ways that you can do that. And I saw people have used Jenkins for that in the past. And essentially anything that you can do in Jenkins, you can do here also in AWS. And just one of the ways that I could think of that you could do that is in your code build step. Now your code build step would get a little bit more complicated if you wanted to execute SQL against a database, for example, where in your code build step, you'd have to package up your deployment and have something ready. So maybe it's a bash script, or maybe it's a JavaScript file, or maybe it's something that you execute within your code build step, so that you could execute those commands against whatever database you want to be actually targeting. I know that's very high level, and again, I'm just trying to respect people's time. I realize we only have 1 minute, so I'm going to get to the third subject here, which is stopping existing applications. And this is a great use case. It happens all the time. And if you have an application running on 3 EC2 instances out there, this is a perfect use case where Jerry mentioned those phases of the build. And in your pre-build step, or maybe even in your build step, or maybe even in your post-build step, depending on how you've orchestrated your events, you stop your application first if you want to be able to stop your application and then deploy. Or if you want a zero downtime deployment, what you can think about is if you have multiple EC2 instances, you can actually do rolling deployments as well. So you can take down one of the EC2 instances, stop that application, just focus on that EC2 instance, then move to the next one, then move to the next one. And obviously we know with Lambda, you're going to be highly available and have zero downtime deployments with Lambda regardless. So hopefully that helps answer all the questions. And I realize we're at time right now. I personally have a little bit more time to hang out if anyone wants to continue to discuss, but I want to take this time to thank everyone. And again, don't hesitate to reach out to us here at Big Compass. So thank you everyone for a great meetup, and hope to see you next time. I'll hang out for a little bit here on the line.
Yeah, and just to echo what Aaron was saying, thanks everyone for joining the call. And also just wanted to point out one thing too. I saw people were mentioning Jenkins, and there is actually some integration the code pipeline can do with Jenkins. You can provide it as an In fact, a build step can either use AWS code build, or Code Pipeline has the ability to add a Jenkins action to it. So I've never actually tried it before, but it is something that you could look into.
Yeah, great point. So just continuing down the list, right? If people are still on the line, and feel free to come off mute at this point. We can have a little bit better in-depth discussion. So Sophie, you asked about what are the limits of serverless and when wouldn't you use it? So you wouldn't use serverless if you're starting to get into more of a hybrid environment. So for example, if you have EC2s deployed and RDS deployed and things like that that are always on, that go outside of your serverless realm, is when you wouldn't use serverless. But serverless, it's our preferred method if we're just dealing with the serverless services on AWS. So, if you have the Lambdas and SQS and DynamoDB and SNS and API Gateway, that I would 100% recommend that you use serverless. It's a really great tool to be able to use and speed up your deployments for those serverless services. Jerry, anything to add to that?
Yeah, one thing we've read about before is the idea of serverless is great for having shared functionality altogether. Like, say you have a user's API, one idea is to have a serverless config for just the API gateway and Lambda functions for that API. But then say you have a shared database across 4 APIs, you would maybe have a separate CloudFormation template that maybe stands up an RDS instance, and all of your serverless YAML configuration templates could utilize that RDS instance by referencing it, but they don't provision it themselves. So you can have multiple configurations for specific functionalities, and then like maybe a CloudFormation template for things that should be shared across different serverless configuration files. So it's there's a lot of ways you could set it up. And one important thing to remember is there is a limit to how many CloudFormation resources you can actually have in a template. So as you saw in ours, we had almost 70 resources, and I believe the limit is something like 200. I can't remember for sure, but that's another reason why you would want to break your templates up maybe into shared functionality, because you don't want to make your CloudFormation stacks too big.
Great point. And to that point, Simeon, I think I'm saying that right, or maybe Simon, asked about declaring the limits. Maybe Simon, if you can be more specific, I'm not quite sure what limits you're declaring or would want to declare, but that Jerry just mentioned one of the limits that you might think about there. So hopefully that answered your question.
Yeah, it is Simeon.
Simeon, yeah, thank you.
Yeah, thank you.
So did that answer your question, or?
Yeah, close enough. That's close enough for
Okay.
my current project, which I am very confused about. But yeah, that is close enough.
Great. Don't hesitate to reach out if you need something.
Absolutely. Thank you.
Mark asked about Pulumi. I personally have not used Pulumi. I'm only familiar with it from researching, and I think it's probably a similar product to the ones out there. And again, to the point that we were making, is that this is just one solution. We've had great success with serverless and with AWS and different flavors of the same thing. So, if your preferred way to go about your continuous integration, continuous deployments is Pulumi, I think that would work quite well from what I know. Mark, is there anything you want to know on Pulumi specifically, or how that might compare?
Yeah, we've looked at serverless, and I think the constraint on the pure serverless architecture is why we left the serverless framework and went with Pulumi or maybe CDK for infrastructure as code, because we operate in a hybrid environment, and so there's some legacy architecture, and also in conjunction with cloud native stuff. So
yeah,
we're still in the ramping up phase, and there's a lot of pain points right now.
Great. Yeah, that's what we've done in the past too. And Jerry and I have thought about this also, and I depends on the scenario, of course, but typically what I would do there is actually just separate out the deployments between serverless and your always on instances, because no matter what, your deployments to your EC2s are I would venture to say are probably at least 80% of the time going to be separate from your deployments to your serverless instances. Maybe you house APIs and different microservices functions that operate independently, right, of RDS and EC2, et cetera. So that's why a lot of times we elect to actually just separate those out. But I totally understand the pros of keeping them all together as well. Thanks everyone for attending. Great questions, great interaction.